All right, good afternoon, Pythonistas. I actually like the sound of that. It's an absolute pleasure to share the next 30 minutes with you. I would like to speak to you as to how, Python and analytics, how it connects to industry. At the heart of, all our initiatives and what you do as a group, as a community, it's around solving problems. So I'm going to bring a perspective as to what industry expects from analytics. What industry expects analytics to enable, across various functions. So very quickly, I'll do a quick introduction into what this is, and I'll tie it to, what industry is looking for. I will also spend some time to share with you some of the some interesting use cases that we have explored, with analytics. The key message here is that while Python and analytics and all those buzzwords, while they sound very fancy, what is key for industry is that you must solve a problem, you must add value. So beyond the complex sounding words, there must be a specific problem that that the solution itself is seeking to solve. And I'll spend a bit more time on the risks. While there are opportunities around analytics, we also need to be careful that and ensure that those capabilities do not become a liability for the business. In this age of data is everywhere. It's important that data scientists and those that are involved in it, they have an understanding as to how things can actually go wrong, because I think that is going to stand you out in terms of the real value that you can add to an organization. I will share some thoughts around how you can implement analytics capabilities in an organization. For those of you that are already embedded in organizations, I'm sure you'll be able to relate to some of those points. For some of us that are yet to be in formal organizations, I guess it will be a strong learning point for you in terms of understanding what it will take to make analytics work in many of our organizations today. So what is clear is that the world has changed, and it has changed quite significantly. Data is everywhere, and there's a lot of value that we can really get from data. So it actually places the Python community or the larger analytics community in a very peculiar position to add value to organizations. So whether it's personal interactions or more commercial engagements, there's data everywhere. And being able to make meaning from that data is what organizations are really looking for. So the ideal data scientist of today should be able to relate to what industry problems are and should be able to come up with solutions that really solve those specific problems. While there are many advances and research programs out there, what industry is looking for is a direct connection as to how to solve problems that impact growth of an organization, that helps to minimize risk and also to manage cost on an overall basis. Because if you look at many of the solutions around analytics today, and many of us must have tried our hands on one way or the other, is around revenue growth, is around managing cost, and is around managing risk, if we are going to put it in three broad dimensions. But really, if we step back and ask, why is analytics really a big thing in today's world? And it's clear, if you compare today to 10 years ago, the bulk of the biggest organizations by value today are organizations that have the biggest data assets. So it actually cuts through that view that if you really want to be successful now and in the future, you have to be a data-backed organization. You need to take data to a whole different level. And if you can see what is presented on screen there, and this might be a couple of months old, but what is clear is that if you compare the top 10 organizations in the world today and compare them to those of 10 years ago, you see that 80% of the value of the world's biggest companies are companies that have the biggest data asset, the likes of Amazon and Google and and Apple and the likes. compared to 10 years ago that it was just barely 20. And that really goes to show that the future of any business, of most businesses, is really centered around data. While it's not good enough just to have the data, where is the value in the data? And that's what I'll be spending some time with you in discussing in the next couple of minutes more. And when we talk about analytics and data, we need to also put it within a larger context, because those capabilities by themselves will not adequately provide a solution for an organization. You will need to embed it and enable with other data-driven technologies, because that is that combination that can really come up with powerful solutions that can be used by not just by data scientists. So when you come up with those long Python codes that deliver the results that you want in the manner that you want it, that's perfectly okay. But for the user in an organization, they need to be able to access it in a practically no-code environment, because not everyone is going to be a data scientist. Not everyone will be familiar with how to manipulate Python libraries and how to run commands on Python. Not everyone will be familiar with that. As a matter of fact, most people in an organization would not be familiar with Python. So what it behoves on us as a community of data scientists, of Pythonistas, is that we need to find a way to make that to unlayer the complexity, the seeming complexity around what we do, to make decision making very easy for the decision maker in a typical organization. And one way of doing this is combining other data-driven technologies to ensure that the decision maker can access that information, can make the decisions in a no-code environment. But as we look at data, and I enjoyed the session by the last speaker, Dr. Folorunshon, where she spoke about data, and to bring the message home, and in terms of what organizations expect. While data in itself, data that is within the organization are really powerful points, points of decision making. But we have realized that the most powerful capabilities are capabilities that combine internal data with external data, whether it's unstructured or structured, and combines it neatly, with various capabilities to really take decisions around insights, what is happening in a business, what the trend is, and what the risk exposure is. The idea behind working all these data points together, whether depending on the level of maturity that the organization is at, is really making better decisions and reducing the decisions that are backed by gut feel and making those decisions more data backed. So what organizations are looking for is how you're able to combine internal and external data, structured and unstructured, to actually enable more powerful decisions. And if you look at the maturity, and what is clear is that many organizations are operating at the lower levels of this particular spectrum. So descriptive and diagnostics, they seem to be quite comfortable, most organizations, with this. But where the Python community comes in, group of data scientists, is being able to support organizations to advance these capabilities to more predictive and more prescriptive capabilities, where we are really speaking to leading edge decision making, where a decision maker has a sense as to what is going to happen, because you have built a predictive algorithm around a particular decision point. But beyond that, you are not telling me that now that you have predicted that something is like to happen, what should it do? The power in this is that the decision maker can take more powerful decisions. So it's taking the complexity out of what we do as a data science community, as a Python community, and making it available to the decision maker. And what this means is, if the executive is able to take better decisions backed by analytics, it means the organization in itself will become more successful. They will become more, they will be able to survive in the competitive landscape. And it's the organizations that can do better, or that can do best in predictive and prescriptive, which is more of the advanced analytics, are the organizations that will survive in the future. So as a group of data scientists, what would be absolutely crucial, as we engage industry is that we are able to help them advance their capabilities beyond their areas of comfort, which is really the descriptive, looking backwards as to what has happened in the past, or the more diagnostic, which many organizations seem to be fairly good at, where they're trying to really come to terms as to why the certain things happen in the past. These are backward looking. Data scientists, we want to be more forward looking, and that is what organizations are looking forward to us to support. So I will share with you some of the use cases that we've seen in industry. And the point I'd like us to take from this is, at the end of the day, if we are not solving a real organizational problem or a real industry problem, whatever knowledge or capabilities that we have does not really make a significant impact. So, as we get deeper in our capabilities, as we get more comfortable with Python, we need to look at opportunities to really advance analytics in industry across various industries. And if you look at what the possibilities are, depending on the industry, it cuts across. Analytics or the use of Python, it touches industries from the banking and insurance to public sector to logistics to even infrastructure and public sector. Technology in itself, while they seem to be fairly advanced in terms of analytics capabilities, they are also useful use cases that that we see around the use of data and analytics capabilities. So regardless of the industry that you are more aligned to, we see that there are opportunities that you can really make a significant impact in decision making. While this is just a selection of where those opportunities are, there is a myriad of other problem areas that industry is grappling with. And what it behoves on us as data science professionals is really to understand, to work with as the subject matter experts to understand where those pain points are and take, very practical steps in creating solutions that can be easily used by a non-data science professional, and they are able to take decisions in a much better approach. So, and if you look at it from a functional view, the uses are also very extensive. So from marketing to HR, where you're using it to predict skill shortage, or to the maintenance group, if you are looking at the manufacturing industry, to customer, to brand management, to risk management, fraud, the uses of analytics are myriad. So what I would challenge us as data science professionals is really that whatever we are experimenting with, it needs to have a direct linkage to industry. While it is very easy to get interested in very advanced capabilities, that is across the entire and the entire globe. If your focus is on Nigeria, I will challenge us that we need to focus on problems that have that really border on the Nigerian organization. It is in those instances that we can make a direct impact as to how analytics can enable businesses, can enable organizations, can enable decision making. While in a broader sense, you can seek to add value to the broader global data science community. So the challenge is, we have a problem. Let's localize that problem and find a local solution backed by analytics to really solve that problem. I think as a data science professional, that is really going to stand you out, in the larger market as a way. So one of the things we look out for, when we engage a group of data scientists, because we want to, let's say we want to select 2 or 3 of them, we look at the practical usage of their knowledge. We look at how relevant the application of what they know, how relevant it has been. So while you can spend time in developing solutions for the larger global community, but a solution that is disconnected from the local community is really not going anywhere, from a local organization point of view. So whatever we are working on needs to speak to existing problems in Nigeria or in Africa before we start to look at how to enable more advanced capabilities that are probably we have not reached that level of maturity, because as you can sense, different countries have different levels of maturity. So being able to advance those levels of maturity from where we are is really what is going to stand out the typical data science professional. And if you go into more specific examples, if you look at the banking industry, it cuts across so many things, from risk management to fraud detection to even having a better understanding of the customer, such that the targeting of marketing and sales initiatives, or even managing the customer, is a bit more appropriate, is more targeted, and then you are able to get more value from your customers, from an organization point of view. So this is for the banking industry, and we've seen examples in many organizations. This is really looking at the legal unit in JP Morgan. In this instance, they are looking at how they can leverage artificial intelligence to review contracts. As many of you know, reviewing contracts is a very cognitive capability that it will require advances in AI to really understand what a phrase is really speaking to. But being able to come up with a solution that helps in having a good understanding and classifying contract process with minimal intervention has really made a significant impact in this particular organization, where an effort that would typically take about 360,000 man-hours, they were able to do it in a few seconds, in a few minutes. And this is one way in which analytics has really enabled this particular organization. They looked at a particular problem and they solved it and reduced the extensive man-hours that is required. But if I now try to make this in your terms, to describe this, in data science terms, what they've actually done is that they've taken that capability around the use of neural networks, in assessing, in classifying phrases, legal phrases. They've built a capability around that and made it available to lawyers, to the learned minds. But the beauty of this is such that those lawyers are not interacting with our Python codes directly. There's an interface around it that makes this realm of neural networks available to the data science professional, but it also now provides an interface for the legal minds to really take the decisions that they need to take. So instead of having a legal team that is manned by 10 individuals, organizations are now seeking to increase the level of efficiency of that team, that instead of 10, I can now have 2, and those 2 are now enabled by neural network capabilities to take the decisions that ordinarily a human would take. So, and what it takes to really do this is really to build algorithms based on an extensive data set that has really been used in the past to classify different legal clauses. We also see a different use in insurance industry, from risk optimization to pricing, to claims prediction. Claims is a big issue within the insurance industry. A significant proportion of the amount that is lost in that industry is lost due to claims fraud. And we are seeing situations now that organizations are leveraging analytics to determine whether an insurance claim is fraudulent or not. So they are building AI capabilities and bots around processing of claims, to the extent that if a claim appears to be legitimate based on how the AI dimensioned it, there's a process to automatically approve that claim. And where there's a suspected case of insurance claim, it now escalates it for a human to have a human review of the circumstances. While this in itself, it addresses a significant proportion of the issues in insurance. But what is clear is that AI in itself, cannot address 100% of the challenges. But what it has done in this instance is that it is addressing a significant proportion of issues in claims processing. So it is that combination of man and machine that really produces superior results for organizations. And that is that expectation that I would like to leave with you, amongst other things, that as we build those analytics capabilities, we should also have in mind that there's a place for subject matter experts. expertise, there's still a place for the human mind to actually intervene in certain instances. And our reliance on AI to deliver 100% of the solutions to a particular problem, we need to look at it with a different mindset. In manufacturing, it also cuts across a number of things that manufacturers are concerned about, from maintenance prevention. Just imagine the cost of shutting down a manufacturing plant just because a small machine in itself just gave way at a time where they were not expecting it. The cost of shutting down that plant, even if it's for a few minutes, it can be quite significant. Because if you realize in the manufacturing industry, the process of restarting a particular line is so expensive that many organizations prefer to leave the line running, even if things are not being produced on it. So being able to leverage analytics in such a way that you can study patterns, you can study data that is being spewed from sensor data, from sensors that are already embedded on equipment. You can start to sense as to when is this equipment likely to fail. So while the equipment has not failed yet, you have a sense as to that the equipment is likely to fail, let's say next week, Monday. But what it now means is that you now have adequate time to work on the line, say on a Sunday night, when the need is not very significant, you can shut down the plant and fix whatever needs to be fixed, and then we realize that by Monday, instead of the predicted default happening, the plant continues to run. So in manufacturing, it actually cuts across many use cases as well. So for those of us that are focused on the manufacturing industry, is being able to dimension where are my capabilities better suited, and being able to focus the analysis capabilities, our comfort levels around Python to solve specific problems that make meaning to industry. And even if we extend it to the public sector or to social services, even in education, we are seeing instances where, analytics is enabling the kind of decisions that we take, where it is helping educators better understand what learners are actually experiencing. When a learner is being disconnected from the learning, there are platforms that really help the educator to really drive focus and focus attention on the learner, or even to recommender systems where you are using it to enable the decisions that is taken in at various levels of administration in education. So depending on the industry, it actually cuts the use of analysis goes in many dimensions. But I would like to just pause very quickly. When we have looked at industry in a broad context, we also need to look at it within the context of where we are as an organization, as a planet, and if I can say that, COVID-19 has really made a significant impact into the ways we work. And if you really dimension and profile the opportunities that we have seen, right from the emergence of the virus in itself, right up to today, we have seen different phases, and we have termed that as resilience, recovery, and then new reality, which is where we are. But the beauty, while this is not supposed to be a beautiful instance, because COVID-19 is really, and it's really been a very disastrous impact on the planet as a whole. But what is clear is that even in very tough times, we are seeing a role for data science professionals, because there are solutions that will still be required to enable many of the things that are required in each of these phases. So at the initial stage, there was concerns around physical contacts. So being able to create platforms that provide information, that help to exchange information, that help to engage our customers, in a no contact manner, were absolutely crucial at a point in time. As we recovered from it, we started to look at how do we enable contact tracing with technology, with analytics. We started to look at that. How do we leverage artificial intelligence and automation to reduce contact levels to the more current levels now that we are organizing a a session around Python today. This is the first time it's going to be virtual. So it shows that, you know, regardless of where we are, there are opportunities that we can layer our analytics with data-enabled technologies to make better decisions, so that whether in good times or bad times, data science professionals will be relevant, and being able to come up with practical solutions that solve real problems. Today's problems are the things that really stand us out, you know, as a community. So as we push the frontiers of data, of analytics, it's also important that we step back to ensure that data does not become a liability for the organizations that we work for. So we need to be careful around data. We need to understand what those risks are around data. So I like to use this example, and this is a example of a newlywed couple, you know, and they've approached their bankers because they want to apply for a mortgage application. In this instance, the banker has a predictive algorithm that determines whether, you know, a couple will likely divorce or not. That decision, you know, that data point is required for them to assess whether this couple, it would be ideal for the bank to lend to this couple, to these two individuals as a couple, because you want to look at it down the line. Mortgage, you typically pay mortgage over a long term, over 30 years, for example. And if this couple is not going to be together in 30 years, then you have a big problem in recovery. While this in itself is a real problem in the banking industry, because they are really concerned around depositors' funds. But how we use analytics to really solve this problem, we need to look at it very carefully. One of it is that, can we really explain, you know, why this initiative is being done? And the thing is this: does it align with our values as a society? You know, when you see a young couple, the first thing you want to do is to wish them well, is to wish them a happy married life. But here, the banker has seen that this group is likely to get divorced within a year. It's not something he can communicate to a newlywed couple. So in that instance, this doesn't meet our requirements or of value, our values as a society. We typically will wish a young couple well. But if you also look at it, how do you explain that to the customer? How do you explain the basis in which that decision was taken, that they are likely to get divorced within a year? No, because the reality of it is that while it is backed by, you know, by historical information, there's also a chance that you can be wrong on this. So how do you explain that to that group? And how do you explain that risk of approving or rejecting, you know, a decision? So how do you explain that you have actually made a decision? Because sometimes you will actually get those decisions wrong. So the concern is there's a lot of benefit in advanced analytics, but we need to be careful in its actual usage. And this is where, as data scientists, you know, as data science professionals, while we can come up with the solutions that really can guide a bank in taking a decision, or an organization, if I use it in a more broader context, we also need to be aware of what the ethics and the values are around those decision points. And we need to ensure that we are not working with an organization to run foul of, you know, what the regulations or the law is. Because at the end of the day, you don't want an algorithm that would support discrimination in any sense. So typically when we talk data governance,
Yomi, we need to start wrapping up.
Okay, so I'll click. I'm actually rounding up now.
Okay.
So you need to understand that, you know, there are regulations that really guide, you know, how you actually take actions on this. So I'll move very quickly to, you know, how we see this actually playing. You know, data scientists, you know, it is one component of a larger field of professionals that will be required to take that are required to come up with solutions. What is important is that we understand that we play one or two roles within a larger context, and being able to leverage the knowledge of subject matter experts, you know, it's absolutely crucial. So while we are deep in our area, we need to understand that there are those that understand the problem code, that understand that industry, and they're able to, we should leverage them to really understand what the problem is and come up with solutions that really make sense for the organization. So in rounding up, we should understand that organizations will continue to leverage and continue to require data science professionals. The need in this age cannot be overemphasized. But we also need to understand that success requires focusing on the business problem and not too much on this, the fancy sounding terminologies around and capabilities around analytics. We must solve a real problem. And then within the larger context, we should be willing to actually advance other data-enabled technologies to solve those problems. And overall, we should be able to manage the risk to ensure that we are helping the organizations to properly situate itself within the regulatory landscape. So those are my thoughts in terms of how we see analytics connecting to industry and how data science professionals can really play a solid role in taking organizations and industry to the next level.